Hey folks, welcome to this episode on predicting double displacement reactions with a focus on gas-producing reactions and neutralization reactions. So recall that a double displacement reaction is the reaction between two aqueous compounds and producing two other compounds. For this to be a double displacement reaction, one of the product compounds has to have a change of state. Either it forms a solid, forms a gas, or forms a liquid, in this case, water. If both of the products remain soluble, there is no reaction. So, in gas-producing double displacement reactions, some of the products that are formed in these double displacement reactions are unstable, and what they do is they kind of automatically decompose into forming a gas. So, examples of these are carbonic acid, which is H2CO3 aqueous, and that will break down into carbon dioxide and water. We have sulfurous acid, which is H2SO3. Remember, sulfuric comes from the sulfate, which is SO4, so sulfurous is SO3 aqueous. It forms sulfur dioxide and water. And ammonium hydroxide, in aqueous format, will form ammonia plus water. Okay? So figuring out these types of reactions actually has two steps. We first have to figure out what the double displacement reaction is. Then we have to identify if it has one of these compounds that is produced as a product. It has one more step. We have to show the decomposition of this unstable product into whatever the gas form is. We actually add these two, and we come up with an overall equation. So let's look at this an example here. In this case, what we have is a sodium carbonate reacting with hydrochloric acid. Okay, so they're both in their aqueous states. The first thing I want to do is, well, I see that this is a double displacement reaction. I have a compound plus a compound, both in their aqueous states. So my elements that I'm going to change up are my cations. So I'm going to leave my anions where they are and change the position of my cations. So I'm just going to draw that up here. So I'm going to have my H and my CO3 together, and then I'm going to have my Na and Cl together. Now to create the formulas, I need the charges. Hydrogen is going to be +1, CO3 is 2-, so I'm going to cross, and Na is 1+, and Cl is 1-, and again I'm going to cross and I'm going to cross. So what I get as products over here is H2CO3 plus NaCl. Now in this case, I have to figure out what my states are going to be. So I look at my solubility table here. Hydrogen with CO3 is going to be soluble, so that means this is going to be aqueous. And again, my NaCl, again, is going to be soluble, so that is going to be aqueous. Now this looks like no reaction has actually occurred because both of the states of the products are aqueous. The difference is that one of these products, the carbonic acid, will actually decompose. So this carbonic acid will go from H2CO3 aqueous into a carbon dioxide gas molecule and water. Now a simple hint is if we actually take our H2CO3 and we kind of subtract H2O from it, what are we left with? Okay, so if we kind of subtract our H2Os and we also subtract 1, what are we left with at the end of the day? We have CO2. So if you remember that, if you remember to subtract an H2O from these ones that are unstable, you'll be able to figure out what actually comes from that. So what this decomposes into is CO2 gas and H2O liquid. Now one thing that we have to do before we go on is we have to make sure that our initial reaction has balance, because we know that this decomposes, so we know that there will be a change in state, a gas and a liquid. So let's just go ahead and balance that. I have 2 NAs on this side and I have a 2 there. Okay. So now when it comes to drawing our full reaction, it's kind of like in math, where if we say we have this compound over here, but this compound equals this, we just kind of substitute this in. I'm just going to rearrange this so I can put my gas and my liquid on the end there. So what I'm going to do is just rewrite it. I'm going to have my Na2CO3 aqueous plus 2HCl aqueous, and that will form 2NaCl aqueous. Now we're not going to write H2CO3 because that actually doesn't occur. It can't be isolated. It breaks down into CO2. So what we do is we substitute what H2CO3 is, and that is going to be plus CO2 gas plus H2O liquid. And there is our final equation. So, with that in mind, take a look at these formulas and see if first a reaction will occur. If it forms one of those products, sulfurous acid, carbonic, or ammonium hydroxide, then you'll have to do an extra step and break it down into the gases that they formed. Once you do that, combine those two equations together and come up with your final equation. So go ahead, pause the video, take a couple minutes to try to figure this out, and we will be back with the answers. Welcome back. Here are your answers here. So in the first one, we have our potassium sulfite with our nitric acid, and we do get two products that are aqueous. And again, we might be able to quickly dismiss this as no reaction has occurred, but we notice that we have H2SO3, which is sulfurous acid. Knowing that we have sulfurous acid and knowing that it breaks down into sulfur dioxide and water, we are able to kind of substitute this in for here, and we get our final equation right down there. Okay? Same thing with the one at the bottom here. We have ammonium chloride reacting with sodium hydroxide. And again, we produce these two products that are aqueous. And again, we might be quick to dismiss it, but again, we see we have NH4OH. We know that this breaks down into ammonia gas and water, and so we can substitute that in and come up with our final equation at the bottom. So another type of special double displacement is a neutralization reaction, and this is when an acid reacts with a base to produce an ionic salt and water. An ionic salt is just an ionic compound. It's a metal with a nonmetal, or more specifically, a cation with an anion. So this is your basic formula. An acid base gives you ionic salt plus water, and we saw that when we were looking at types of reactions. Just recall that what an acid and a base is. An acid is something that has a H+, or as we call it, a proton. Okay, because if you have a hydrogen without an electron, it's basically just a proton there. And also some other non-metal anion. A base is something that has a metal cation, but more so it has that hydroxide ion. Now, when you react an acid with a base, these two, this metal cation and the non-metal anion, they'll come together to produce your ionic salt. And the H and the OH, they'll come together to produce, well, if you have two H's and one O, it'll produce your H2O. Okay, so that's where we get our products from. An example of an acid is something like nitric acid. Here you have our hydrogen and a nitrate group. When you put this into water, it actually breaks up into its ions, H plus and NO3 minus. And this is it's called ionization, where it takes a compound here, an ionic compound, and breaks it up into the H plus and the NO3. Now, why ionic? Well, this is not a metal. You're saying, hey, that's not a metal, it's not ionic. Well, it's not a metal, but it is a cation. Okay? And this is an anion, so it's an ionic compound. When we have NaOH, again, when we put that into water, it ionizes, it breaks up into Na plus and OH minus. So here's our H plus, that's why we consider that an acid, and here's our OH minus, that's why we consider that a base. So a more specific general definition or general equation of this neutralization reaction is here. So here we have our acid, HX, our H plus our anion, and we have MOH, which is our metal cation, and our OH, that's our base. So the metal cation and the non-metal anion will come together to form ionic salt, and the H and the OH will come together to create water. And this is an example using these two examples here. What we'd get, we get NaNO3, which is our aqueous ionic compound, and we get some water. So here's an example of a neutralization reaction. First thing we have is perchloric acid and aqueous potassium hydroxide. So the first thing we need to do is figure out what is the formula for perchloric acid. Now, remember how we named these oxy acids. Ic comes from the suffix ate. So perchlorate. If you remember, what's chlorate? Chlorate is ClO3 minus. Perchlorate means that there's one extra oxygen, so that's going to be ClO4 minus. Well, this is an acid, so it also has to have a hydrogen. So if we have H and ClO4, the charge here is +1, that is -1. And all we do is we cross-cross, so it's that there, and we get HClO4. Now this is an acid, so it is going to be aqueous. Aqueous potassium hydroxide, again, to get this, we have potassium KOH. Charge here is +1. This is minus, cross, cross, and we get KOH. Again, it says that it's aqueous, so we'll put aqueous. Okay, so here we have something that looks like an acid. We have H and we have OH. So that will create our water. The only thing that we have to figure out is what is our salt going to be. So that is going to be our metal. That's going to be our M, and this is our X, which is ClO4. So we have KClO4. We have to figure out what the formula is. So again, this is +1, this is -1, cross, cross. We get KClO4 plus H2O. Now H2O will have a state of liquid, and we'll have to use our solubility table to figure out what the state of KClO4 is. Now, if you go to your solubility tables, you'll figure out that it is going to be aqueous. Generally, these ionic salts that are created in neutralization reactions are going to be aqueous, but always make sure you check using your solubility table. Last thing we need to do is balance. We have one ClO4 here, 1K, OH. There's our OH with an extra hydrogen, so it is balanced. So take a couple minutes and try to figure out what the products of these reactions are going to be. Okay, so come up with the products and balance. Also try to figure out your states using your solubility table. So go ahead, pause the video, and we'll be back in a couple of moments. Alright, welcome back, folks. So here we have hydrochloric acid and aqueous calcium hydroxide. And so again, we had to create our formulas initially, which is HCl aqueous and CaOH2 aqueous. We noticed that the two things that are going to switch places we're going to have our calcium with our chlorine to create calcium chloride. And again, we're going to have to use our CaCl. This is 2 plus, this is 1 minus, cross, cross, and we get CaCl2. And our OH will bond with our H to create our water. We balance it, and we get our final balanced equation. The second one here is simple. Our lithium will bond with our sulfates. Again, this is going to be, if we have Li and we have SO4, this is 2 minus, this is 1 plus, cross, cross, we get Li2, SO4. We look at our solubility table, that's aqueous. And again, our OH and our H will bond to create our water. So that's it for this. Thanks very much for watching. See you soon.